Hello, this is Bharat from TVK Career Point channel. So now we are going to discussing about what is the process of building the CNN or develop the CNN model from the scratch. సో సిఎన్ఎన్ మోడల్ బేసిక్గా బిగినింగ్ నుంచి ఎలా డెవలప్ చేయాలన్నది కాన్సెప్ట్. సో టు బిల్డ్ ది సిఎన్ఎన్ ఫ్రమ్ ది స్క్రాచ్, so what are the steps need to follow? So that is discussed in this video. So let us discuss step by step. So first of all, so once the software part is ready, and if you are integrated the TensorFlow and Keras TensorFlow into the Anaconda platform, you need to work on the Jupyter notebook. So on the Jupyter notebook, so we can write the code, and from there we have to start building the CNN model. So in the as a first step, first of all we need to take the importing libraries and data. So this is the example case we are discussing, but it is changing from project to project. It is changing from uh, model to model, and as and when required, the different kinds of model libraries we need to import them subsequently, as per the data set and as per the project and as per the application, and as per the requirement, right? This is just example we are discussing, but however, this is the process of building the CNN model from the beginning, right? So we need to import the TensorFlow, import TensorFlow as TF, and from TensorFlow we need to import Keras. From TensorFlow dot Keras import layers, import NumPy as NP, so for mathematical calculations. Import matplotlib dot pyplot as PLT, it is for drawing the graphs, accuracy graph, loss graph, or some other. So if you want to print those graphs, we need to import the libraries. At the same time, these are the examples. However, so you can go to the keras.io. So there you can find all the libraries are available. So manak requirement, based on the requirement, you can take that libraries and you need to add into the code. Import model, and if you want to import anything is required, like dense layers, convolutional 2D, convolutional, any other dense layers. So what and all required, you need to take all those libraries, you need to import all those libraries. Just I want to show as a step one, so what should be there at least. So the step one, you need to import the libraries. Now let us go to the step 2. So step 2, you need to pre-process the data. So data, once you download the data set from any type of repository, either you can take from Kaggle or any type of data websites are there, many data repositories are there. So in the case of CNN, generally we are taking all the image, it is for image classification. So you can download all the uh, images from image folders from the any type of repository. And once you downloaded the data set, so we have different kinds of uploading the data set into the Jupyter notebook, or else if you are working online, you have to import to the Colab, Google Collaboratory. So different kinds of platforms are there. However, we need to import the data, that is important. So once the data is imported, or once the data is ready, you need to before building the model, we need to pre-process the data. Okay, so to pre-process the data, we need to perform some operations like resizing, splitting into training and validation sets. Ante, so the data set, you have to perform these different kinds of operations. So we have to divide the data into training, validation and testing, separate folders, and some different ratios. So different kinds of ratios are there: 90 training and 90 training and 10 testing, or 80-20 ratio. Or else we can, if you take the train, validation, test, then you have to divide them into three folders, and the ratio will be of 70 10 10, 70 15 15, or 80 10 10, are 60 20 20. So different kinds of ratio we have to work. So however, it depends on the how you are building, and once the application is done, and we need to work more on it. So however, the process of pre-processing should be done for the data set to overcome the problem of blur, or to overcome the problem of noise, or to overcome the problem of any other problem with the image. So image నుంచి ఎటువంటి ప్రాబ్లం లేకుండా we need to perform the pre-processing data to detect to give the input as a clean image. And however, the normalization of the pixel values will be in between 0 to 1, and one hot encoding the labels. So for that, generally example x train equal to x train by 255. So we are scaling between 0 to 1. The values should be between 0 to 1 కాబట్టి whatever the x train you are taking, so that will be divided with by 255, then it will be converted into in terms of 0 point something, 0 0.1, 0 0.2, 0 0.6. So in between 0 to 1 only these values will be arranged. So this is the step 2. So after importing the libraries and uploading our the data or pre-processing we have to perform, then we need to move to the building the model. So to build the model, first of all we have to initialize your CNN model. So to initialize the CNN model, importing library, there we have to import the sequential model and convolutional 2D model, all the layers from the tensorflow.keras, all layers we have to import from them. So this all complete idea we can see, you can see in the keras.io. And so we have to add convolution layer and follow it with a pooling layer. So we need to write that code. This is the building the model. I will show you example. This is just example, not the complete code what we are giving. So but this is the initial procedure to follow to build the CNN. So this is example model keras.sequential. So before writing this code, you need to import that model, sequential model, from the import library, importing libraries. Layers.conversion 2D, filter size is 32, kernel size is 3 by 3, activation is equal to relu, and input shape is of 32 by 32 comma 3. So this is already we have explained what is the purpose of filters. So in the case filters, if you take here, this is layers, convolutional 2D and max, this is one set, one layer, and this is one set, and this is one set. So after that I will go to the flattening. So as we already know that the basic architecture of the CNN, after completing the feature extraction part, we need to move for converting into the one dimensional, and then I will supply to the fully connected layers. So finally we have to get the output. So here the filters can take 32, 64, 128, 256, or you can take any number of filters. If you want to take, you can take, no problem. And kernel size is of you can take 3 by 3 or 5 by 5 or 7 by 7, whatever the size if you want to give. So it depends on the model structure. So your model should be unique, and you can give your dimensions, and I need to verify the result. So the result is okay, then you can stop refining and tuning everything, all the parameters, as we already discussed many times in the previous videos, the parameters and hyperparameters and what are and all required for building the CNN model. And activation relu, and input is 32 by 32. In our example, just I took the 32 by 32. 3 is the input channel, so it is the image is a type of RGB color image, that's why it is a 3. So pooling size generally it is a 2 by 2 we took. And in the case of second layer, the number of filters are 64. And so ఈ కేసులో మళ్ళీ అగైన్ ఇన్పుట్ షేప్ అనేది రాయక్కర్లేదు, ఆల్రెడీ ఇనిషియలైజేషన్ ఇచ్చేసాం కాబట్టి. So likewise we need to write the number of layers, but these number of layers are not constant. So static, you can give the any number of hidden layers you want, so you can expand it, but it depends on the result, how do you get. So if you meet the requirement, so it depends on the model is leading towards the overfitting or towards the underfitting. Then what are the measures we need to perform? As already we know and we have discussed, in the case of underfitting, in the case of overfitting, what measures we need to take, like the solution for overfitting, like a regulation technique we need to perform, like using regulation techniques called L1 L2 or dropout or early stopping mechanism or data augmentation we can perform. And in the case of underfitting problem, we can perform the increasing the number of hidden layers and increasing the executing the code or executing the epochs or increasing the more number of epochs is also one of the solution for it. Okay, one second. So after doing this, the model is completely depends on the your data set and your work only. And after that you need to print that model. The model you have to print. So if you print that model, then you can able to see the how many parameters, what are the training parameters you have taken, or else after building this model, how many learnable parameters or trainable parameters వచ్చాయి అనేది మీకు మోడల్ డాట్ సమ్మరీ క్లిక్ చేస్తే యూ కెన్ ఏబుల్ టు సీ వాట్ ఆల్ పారామీటర్స్ అట్ ఈచ్ లేయర్. సో లేయర్స్ దగ్గర కన్వల్యూషన్ లేయర్లో ఎన్ని పారామీటర్స్ వచ్చాయి అనేది మీకు కనపడుతుంది. యూ కెన్ ఏబుల్ టు సీ ఆల్ ది కంప్లీట్ పారామీటర్స్. ఇక్కడ డెన్స్ లేయర్స్లో 128 న్యూరాన్స్ వీ హ్యావ్ కన్సిడర్. And here you can also change 256 and 520, 256 and 512 also, 1024 also. The number of neurons you want to supply for the fully connected layer, that depends on uh, the result, right? If the result is good, no need to go for supplying of the neurons. However, we can apply the regulation technique also in the model between the fully connected layers, like a dropout of 0.5 0 to 1, 0.1 or 0.2 or 0.3 or 0.4. So that many number of 50% of neurons will be disconnected from the network, and remaining will be supplied. And this indicates the number of classes in your the output final output neurons. The number of, it depends on the number of classes. So in the case of binary class, generally will takes sigmoid function here activation. So in the case of multi classification, so we'll take the softmax here. So just in our case, we can assume that if it is a softmax function, if it is a multi classification, then it is a softmax, right? So if it is a binary classification, generally the output will be either one, this or that, అంటే ఒకటే వస్తుంది కాబట్టి then the output layer will be one here. So instead of 10 layers, 10 classes, here only one class will be there. Then the activation function will be one on sigmoid. So after that we can able to type the model dot summary. So in that model dot summary you can see ఏ కన్వల్యూషన్ లేయర్కి ఎన్ని పారామీటర్స్ క్యాలిక్యులేట్ చేసింది అనేది మీకు వస్తుంది. ఆఫ్టర్ దట్ ఫుల్లీ కనెక్టెడ్ లేయర్ డ్రాప్ అవుట్ ఉంటే డ్రాప్ అవుట్, బ్యాచ్ నార్మలైజేషన్ ఉంటే బ్యాచ్ నార్మలైజేషన్. ఆఫ్టర్ ఆల్, సో ఫైనల్ ది టోటల్ నెంబర్ ఆఫ్ పారామీటర్స్, లర్నబుల్ పారామీటర్స్, ట్రైనబుల్ పారామీటర్స్ మోడల్ నుంచి వచ్చింది అనేది మోడల్ డాట్ సమ్మరీ. యూ కెన్ ఏబుల్ టు సీ ది టోటల్ నెంబర్ ఆఫ్ లర్నబుల్ అండ్ ట్రైనబుల్ పారామీటర్స్. సో దిస్ ఈస్ a very important part in the model building. So because of to get the proper result, this is the main heart of the model. So that's why it is called model building. Of the model, defining of the model is, it plays very important role. As we already discussed the pooling, max pooling we took here example. So you can also take average pooling, but example purpose only we discussed here. But we can change the number of filters, and we can change the kernel size, and we can change the image size also directly, and you can see the result how it is working. So after this step 3, we can move to the fourth step, which is called compiling and training the model. So compilation is 100% required. After building the model, we need to compile it by specifying the loss function, optimizer and metrics. So it is a very important. In this example, we'll use the categorical cross entropy loss function and the Adam optimizer and accuracy as the metric. So మన మోడల్ ఈ మోడల్లో వాట్ ఈస్ ది మెట్రిక్ అంటే accuracy is the metric just we consider. But in the other case we can also print the all performance metrics like once you calculate this metric, then you will get automatically the precision, recall and AU score or F1 score. So these all we can able to take them as performance metrics. And once in the evaluation, the examiner asks what are the parameters, performance measures you taken for your model, then you have to say that the precision, recall, F1 score and the classification accuracy. So these are some of the metrics I took, and you need to display that in the separate table. Then we'll get a clarity how the model works. After will the train the model for 10 epochs using batch size of 32. It is completely dependent on the model. It is an example only. So the number of epochs, number of batch size, batch size, image size, filters, and kernel size, the dropout. These all are completely dependent on the model you are taking. So మీరు బిల్డ్ చేసే మోడల్లో ఇవన్నీ కూడా చేంజ్ అవ్వచ్చు బికాస్ ఆఫ్ యాజ్ వీ ఆల్రెడీ నో దట్ అది హైపర్ పారామీటర్స్ కాబట్టి వీ హ్యావ్ టు ట్యూన్ ది మోడల్ ప్రాపర్లీ విత్ యువర్ ఓన్ హైపర్ పారామీటర్స్ అంటే డైనమిక్గా యూ నీడ్ టు రిఫైన్ దెమ్. చేంజ్ చేస్తే ఎన్ని నెంబర్ ఆఫ్ ఎపోక్స్ రన్ చేయాలి, బ్యాచ్ సైజ్ ఎంత చెక్ చేస్తే 32 వస్తే బాగా వస్తుందా. సో బ్యాచ్ సైజ్ వీ కెన్ ఆల్సో ఇంక్రీజ్ from you can start the batch size from 1 to any number of batches we can divide. And for example your sample size is 5000 or 10000, so we have to divide the total number of samples into train and test. So train and test మీరు 80-20 డివైడ్ చేస్తే ఇఫ్ యూ 10,000 ఇమేజ్ని ట్రైన్ అండ్ టెస్ట్గా డివైడ్ చేస్తే 8,000 ట్రైన్ అవుతుంది అండ్ 2,000 టెస్ట్ అవుతుంది. 8,000 ట్రైనింగ్లో సో వీఆర్ ట్రైనింగ్ ది మోడల్. సో ట్రైన్ చేసేటప్పుడు సో మీరు బ్యాచ్ సైజ్ అనమాట, ది టోటల్ నెంబర్ ఆఫ్ శాంపుల్స్ ఇన్ ది ట్రైన్ బై బ్యాచ్ సైజ్. సో దట్ ఆర్ ది టోటల్ నెంబర్ ఆఫ్ బ్యాచెస్ ఆర్ అవైలబుల్ అనమాట. ఇప్పుడు 8,000 బ్యాచెస్ 8,000 శాంపిల్స్ ట్రైన్లో ఉంటే 8,000 బై ది బ్యాచ్ సైజ్. సో బ్యాచ్ సైజ్ మీరు 32 తీసుకుంటే టోటల్ నెంబర్ ఆఫ్ బ్యాచెస్ ఎన్ని వస్తాయి. So or else if you want to take the batches as 64, so that many number of batches will be divided. So ఆ బ్యాచెస్ అన్నీ కూడా 1 by 1 బ్యాచ్ అనేది ట్రైనింగ్ స్టార్ట్ అవుతుంది అనమాట. ఆ బ్యాచ్ కంప్లీట్ ట్రైనింగ్, అలాగే రిమైనింగ్. సో టోటల్ నెంబర్ ఆఫ్ క్లాసెస్, ఆ టోటల్ నెంబర్ ఆఫ్ ట్రైనింగ్ శాంపుల్స్ విల్ బి ట్రైనింగ్ ఇన్ టర్మ్స్ ఆఫ్ బ్యాచెస్. సో ఆ బ్యాచెస్లో ఎన్ని ఎపోక్స్ రన్, అలాంటిది ఎన్ని సైకిల్స్ మీరు రన్ చేయాలన్నది that depends on your result. So 10 epochs ke sometimes you may get the result for 10 epochs, sometimes you may get the result for 100 epochs also, sometimes we may not get. That depends completely on the model type and data set and what are the measures you have taken and what are the optimizers you took and what is the loss function metrics, and these all are shows the impact on the result, right? So this is the compilation part. We can see the example how to write the compilation code. So this is the compilation code model.compile of loss function వచ్చేసి categorical cross entropy. So we already discussed in the previous videos about the loss functions. So the loss functions are different, many types. For classification generally we will take binary classification, BCE type of entropy function, and it in the case of multi classification generally will take categorical cross entropy. So మన ఎగ్జాంపుల్ మల్టీ క్లాసిఫికేషన్ అనుకున్నాం కాబట్టి then we can take the categorical cross entropy. Optimizer, so optimizer we are taking Adam optimizer, and we are very much familiar with the back propagation to tune or to get the optimized result for the change of weights kabatti. So the optimizer, what type of optimizer we have to take another. So if you want to see what are the available optimizers, you can go to the keras.io, keras.io. Keras dot so website lo you can able to see all the different kinds of optimizers, and you need to verify which optimizer is working properly for your model. So we cannot say that the we can also take HGD optimizer or RMS prop. So generally the people are taking Adam optimizer because it is a combination of adaptive gradient and SGD. So we can also work with a different type of optimizers, and that report you need to mention in the your presentation. So I have I changed different kinds of optimizers, and this is the result I got. అట్లా అలా you need to mention అనమాట. And then finally the metric is taken here in the case accuracy తీసుకున్నాం. This is the compilation part. Next very important part is train. So train the model. History equal to model dot, it is a variable, so equal to model dot fit, దీన్ని ఫిట్టింగ్ అంటాం. model dot fit x train y train. సో మీరు పైన ఏ తీసుకున్నారో ఆ వేరియబుల్సే యూజ్ చేస్తారు ఇక్కడ. బ్యాచ్ సైజ్ ఈక్వల్ టు 32. Just now we have discussed about complete information regarding the batch size. The batch size, it is optimal batch size is from the review and from the surveys. Generally the people are taking 32 as the batch size, but we can also work with the 64 and 128 to 56 batch size, or else 16 batch size, 8 batch size also. But we need to note down what is the result we got and how much accuracy we got. We need to note down everything as part of the research work, and then we need to confine that for which batch size we are getting the optimal result, for which batch size. And these all are parameters, hyperparameters. We need to note it down on the table. After working hours together, it will not come for a 10 minutes or 20 minutes or one time at 1 hour, 2 hour, 3 hours. It takes a lot of time, days together, to build the proper model, because of depends on the data set, and depends on the number of samples are there in the model, number of samples are there in the data set type. And finally it depends on the type of application what we are taking, and depends on the type of area we are taking. So these all are the uh, important parameters we need to keep in our mind. So this is about the compilation and training model. Then we'll move to the next step. It is a important step, evaluating the model. So for evaluation, so to show the to see the performance of testing. ఇప్పుడు ట్రైనింగ్ అయిపోయింది. If you want to check the అది మోడల్ ప్రాపర్గా వర్క్ చేస్తుందా లేదా అనేది we can able to see on the testing part అనమాట. So evaluate the model. So test dot loss comma test dot accuracy model dot evaluate. So you can print that loss graph, తర్వాత accuracy graph and loss graph both are will be printed. So then in that the graphs we can able to see, so the proper the model is converging with the data set properly or not. So what about the testing percentage and training percentage, model overfitting or underfitting. So how much you got, and what is the prediction. You need to print that the detection is done properly or not. So and you can also print the one more metric like a confusion matrix. You can also print the confusion matrix, then you can able to see that the what are the misclassified and classified properly or not classified properly, classified and misclassified. Then you can able to see in that matrix very clearly. Then we can again go back to the model and refine the parameters and change the layers and change everything, and you can run. So this is a continuous process we need to perform until you get the required percentage and required outcome or output. Okay, so this is the step 5 of what do you call evaluation. and final step is visualizing the result. So the visualizing result is very important because of we need to print that graphs to understand or to show and to explain or discuss in the as part of the result. After printing for printing this, we need the library called matplotlib. So we need to import this in the library part only. So and we can write this code. This is plt. It is a variable for the matplotlib plot. Plt dot plot of this is a variable of compilation history dot accuracy label equal to training accuracy. We can change these words and it will be printed legend show. So the type of graph లో ఎక్కడ టాప్ లో ఉండాలా మిడిల్ లో ఉండాలా అనేది ఇట్ ఈస్ ఎ టైప్ ఆఫ్ ప్లేసింగ్ ఆఫ్ యాక్యురసీ అనమాట. ఈ లేబుల్స్ ఎక్కడ ఉండాలి. సో దట్ ఈస్ ది విజువలైజేషన్ పార్ట్. సో వన్స్ ఫర్ ఆల్, సో ఇఫ్ యూ హ్యావ్ కంప్లీటెడ్ ఎవ్రీథింగ్, so then you need to verify, you need to print the performance metric like precision, recall and F1 score also for all the classes which are available in your data set. And we need to print the confusion matrix also for all the confusion matrix. It contains all the classes which are predicted truly, which are not predicted truly. The అది ప్రింట్ చేసిన తర్వాత we can able to assess how the model is going on. So once the result is satisfied, and we can stop the training and testing, and the model we can able to save and deploy. ఇది ఇంతవరకు ఫినిష్ అయిపోతే అదే ఈ మోడల్ని మీరు సేవ్ చేసుకొని వీ కెన్ ఏబుల్ టు ఫైనలైజ్ ది మోడల్. దెన్ యూ నీడ్ టు ఈ మోడల్ని ప్రపోజ్ చేసేటప్పుడు వీ నీడ్ టు కంపేర్ దిస్ మోడల్ విత్ ది ఎగ్జిస్టింగ్ మోడల్స్. సో ఎగ్జిస్టింగ్ మోడల్స్ ఆర్కిటెక్చర్స్ ఏమున్నాయో వీ హ్యావ్ టు వెరిఫై. సో existing model, the it depends on your the what do you call the problem statement. It depends on your the title or application. So we need to compare అంటే సేమ్ వర్క్ మీద ఎవరైనా చేశారు లేదో we have to verify, and what is the architecture they were used and what we proposed. So what is the comparison. So did I get the good accuracy or good result or not. We need to verify, and we need to show the table, the comparison table also we have to show. So if you want to work with the pre-trained models also, we can execute your data set with the pre-trained models, and the model which is developed by you. ఈ రెండు మోడల్స్ ప్రీ ట్రైన్డ్ మోడల్ ద్వారా మీ డేటా సెట్ చెక్ చేయడం, అండ్ మీ మోడల్ న్యూ ఓన్ మోడల్ రిజల్ట్ వెరిఫై చేయడం. సో వీ హ్యావ్ టు కంపేర్, somehow we need to compare with the other models, and we need to write the comparison of the models. Finally we need to compare the result, and finally we need to conclude the conclusion must be there. In that conclusion we need to write that the total number of samples or whatever is the result we got, and with which we have compared, and everything we need to mention, and then we can close it. So this is the basic concept as we discussed in all the steps. Step 1, step 2 pre-processing, step 3 model building, 4 compilation, and 5 compilation and training, evaluation, and visualization, and along with confusion matrix printing along, and also the performance metric also we need to print, and we can able to save, and finally we need to compare, and then we can come to the conclusion that the model is performing so and so percentage, and with after completing the problems like overfitting and all, then only we can able to deploy the CNN model. So this is the how, at least these number of steps on this is the work we need to present for if you want to build the model, right? So I hope you got the point. Then just if you are understood this, just follow and like the video and share to your friends also. That's all for now. We'll meet in the next video with the new topic. Thank you all.